All right, this is Mr. Smith here. This is Algebra 2, and we were preparing for a quiz on sections 8.5 and 8.6. We're looking at rational expressions in 8.5 and looking at rational equations and solving those in 8.6. And so here are 5 problems that will resemble the problems on the quiz tomorrow. So let's get at them. So this first one is a rational expression. For rational expressions, we need to find a common denominator, and then we need to add, or in this case, we need to subtract. So I see this fraction has an x plus 4. This one doesn't. So we're going to add it in. But remember, whatever I do to the denominator, I have to do to the numerator. And here this guy has an x plus 6, and this one doesn't. So I need to add that in as well. Okay. Now I have a common denominator, which is x plus 4, x plus 6. And so I'm going to write everything as one fraction. So this becomes 3x plus 18 minus, and for the moment, let's leave this as x plus 4 like this. The reason I do that is because I want everyone to see, we need to see that this minus sign is going to get distributed to the entire second part of the fraction. So this becomes 3x plus 18 minus x minus 4. All over x plus 4, x plus 6. So in the spirit of cleaning up the numerator, this is going to be 2x plus 14. All over our denominator, x plus 4, x plus 6. And then the last step is we try to factor the numerator if it factors, and if it cancels, we want to cancel. In this case, it does factor by a common term of 2, but nothing's going to cancel, and so we're done. Like that. Okay? This is a problem where we are adding or subtracting fractions. It is a rational expression. We cannot get rid of the denominator here. Okay? We cannot get rid of the denominator like we will on the next problem. All right, so this problem is a rational equation. All right, we need to compare the two problems. This is a rational equation. The other one was a rational expression. So rational equations, we can get rid of the denominators, and we want to. And the way that we do that is by multiplying by the least common denominator. Okay. So in this case, the least common denominator is x plus 1 times 2x. And so we're going to multiply everything, every term gets multiplied by x plus 1 and 2x. And to know if this is successful or not, to know if we chose the correct denominator to multiply by, all the denominators should clear out. They should all cancel out. And so in this case, the x plus 1's here, and here cancels, and it leaves us 2x times 3x, minus, in this case, the 2x's cancel, and it leaves us 5 times x plus 1. And in this case, the 2x's cancel, and it leaves us 3 and x plus 1. And so what should happen is we should take our rational equation, and it should be transformed into a, in this case, a linear or a quadratic, which is what we are at this point, quadratic equation. So 2x times 3x is 6x squared, minus 5x minus 5, make sure we distribute correctly, equals 3x plus 3. Set everything equal to 0. So this becomes 6x squared minus 8x minus 8. Again, this is all even, so let's make this look a little nicer. 3x squared minus 4x minus 4. And now hopefully this thing factors. Let's see how I did. No, one of those should be plus. does that work? Right, 3x times x, 3x squared, 3x times minus 2 is minus 6, plus 2 is minus 4, and then the minus 2 times positive 2 is negative 4. So these are our two factors. So 3x, so x equals 2, and x equals negative 2 over 3. Neither one of those makes 0 in the bottom, so both of these should work. Okay? All right, next problem. This is a rational equation that is a proportion. How do we solve proportions? We cross multiply. So we get x minus 3 times x plus 2 equals x times x plus 5. So this is x squared minus x minus 6 equals x squared plus 5x. In this case, it looks like both x squareds drop out. So negative x minus 6 equals 5x. I add x, divide by 6. So negative x plus 5x is 6x divided by 6, and x equals negative 1. Again, that doesn't invalidate, that doesn't make any of the denominator 0, so we should be fine there. Okay? All right. Next problem. This is a complex fraction, a fraction within a fraction. The goal here is to be able to combine the two fractions on the bottom. But to do that, we need to get a common denominator. So the common denominator in this case will just be x times x plus 1. And so this gives us our common denominator. And now we can write this as 4x plus 6x plus 6, which is 10x plus 6 over x times x plus 1. And the last piece of this is the 10x plus 6 factors by pulling out a 2. And so it gives us 5x plus 3 all over x plus 1. But remember, all we've done is we have simplified the denominator of this big fraction. Right, so all we've done is taken this guy, and instead of having two fractions, we've written it as one. And the reason we want to do that now is because I can think of this problem as a big division problem. It's a big division problem. And so we can rewrite it, and we can go 16 over x minus 2 divided by this guy, which is 2 times 5x plus 3 all over x plus 1. And now, how do we divide two fractions? Flip the second and multiply. This is 16 over x minus 2 times x plus 1 over 2 times 5x plus 3. And at this point, nothing really cancels except for the 16 and the 2. Everything else looks like it's unique, and so there shouldn't be anything canceling. And thus, we get 8x times x plus 1 all over x minus 2, 5x plus 3. And that's our final answer. Nothing else will cancel there. And so, there we are. All right. So one last problem. This is a rational equation, and it is not a proportion. Okay, so I cannot use my cross products, cross multiplication approach. The approach here is to find a common denominator, and I'm going to multiply everything by the common denominator. But to help me understand, or to help me see what the common denominator is, I want to factor this x squared minus 1, so it says x plus 1, x minus 1, and plus 2. Okay. So it's pretty obvious now, I hope, that the common denominator is going to be x plus 1, x minus 1, and we're going to multiply everything by that. And again, when we're multiplying here, we're literally multiplying the numerator, and we're doing it to the purpose of canceling out the denominator. So, here the x plus 1's drop, and we're left with 3x, x minus 1. Here the denominator completely drops, and we're just left with 12. And here we get the 2x plus 1, x minus 1. And we have now transformed our rational equation into a quadratic equation. So we can go through and solve now. 3x squared minus 3x equals 12. I would tell you to FOIL this first and then distribute the 2. So this should be x squared minus 1. So it's not too tough, but still just to avoid confusion. We need to bring everything over to one side. So let's take everything over and bring it over onto the left side. So 3x squared minus 2x squared is x squared. It looks like there's no other x term. 12 minus 2 is 10, but I want to bring the 10 over to the other side. And so there we are. Now, at this point, this may not factor tomorrow. It should. Let's say 9 problems out of 10 will factor, but you may see one tomorrow that does not factor. At this point, if you get to this point and you come out to an equation that doesn't factor, you should stop for just a moment, and you should double check your work. Make sure you didn't make a careless mistake. Otherwise, you got to use the quadratic formula here. Okay. Now, in this case, this problem does factor, which is nice, so it'll be x minus 5, x plus 2, and x equals 5, or x equals negative 2. And there we are. Those are the solutions. We should plug them back in, make sure that they don't make the denominator 0. There will be one word problem on the test, and it will come from one of the 4 word problems on pages 606 or 607. Again, there will be one problem on the test, and there are 4 word problems between pages 606 and 607, and it will be one of those 4. So I'd encourage you to look through those 4 tonight, gain some experience with them, so that when you see it on the quiz, you're prepared. Thanks for your attention. Good luck in your studies. Mr. Smith, signing off.